All right, DNS Exam 3, problem number 35. Remember, being number 35, this is a calculator question, which I think is going to be important right here. So in this problem, I kind of chicken scratch the directions right here. It says that f is an antiderivative of this expression right over here, tangent squared of x over x squared plus 1, such that f of 1 is equal to 1/2. So they gave you that, and we're supposed to come up with the value of f of 0 right over here. I actually kind of misinterpreted this when I looked at it at first. I saw this expression right here of the tangent squared of x over the x squared plus 1, and I got to thinking about some type of u substitution problem with the recognition right there that 1 over x squared plus 1 is a derivative of something related to tangent. But as I try to think about it and set it up a little bit more, that of course is the derivative of inverse tangent, which doesn't really apply here. But what is interesting here is that they've given you the value of f at 1. They want you to come up with the value of f at a different spot. That is usually an indication that we're going to be using fundamental theorem of Calc Part 1. So if we just try to translate what's going on right here, we are dealing with an antiderivative of this particular function right over here. So what we're going to do is we're going to set up an antiderivative or an integral of that exact expression that they gave us here, the tangent squared of x over the x squared plus 1, and we're going to take that with respect to x. Now, anytime you're doing an integral, what we have to do then is to take the antiderivative of the integrand right here. And they've told us in this problem that f itself is an antiderivative of that function. So, what's going on right here? Don't write this down just yet, but an indefinite integral of that function would be f of x, and technically we would put a plus c at the end right there because the way that we set it up was as an indefinite integral. But if we look a little bit more closely at the idea that they've given us the value of f of 1 and they want the value of f of 0, that kind of shows us that rather than looking at this as an indefinite integral, we really should have looked at it as a definite integral, with these two numbers here, 0 and 1, as the limits of integration. So now if we think about what fundamental theorem of Calc Part 1 tells us, anytime we go to evaluate a definite integral, we take our integrand right here and we anti-differentiate it and put that function right over here. Well, they've told us in this problem that f is an antiderivative of that particular integrand. So what this really is that f of x is our antiderivative, and we're going to evaluate that now from 0 to 1. Or, to put it another way, usually we skip that step that I just wrote there. Actually, let me write it up here. This could be written now as f of 1 minus f of 0. So thinking about that right side there, let me slide this guy down just a little bit. Thinking about that right side, we know that the value of f of 1 is 1/2. We don't know the value of f of 0. In fact, that's what we're looking for, so I'm fine not knowing what that is, but it's the left side that's troublesome. And I'll bet a lot of you guys looked at this problem and said, uh-oh, I don't know how to integrate that. That's what I thought for a second there too, and then remembered, oh yeah, this is a calculator problem. So let's go back to, I hit it somewhere. All right, let's go back to our CAS right here, and let's go ahead and try to evaluate that definite integral. So I'm going to go to Tools here, Calculus. This is menu 43 for you guys, and we are doing an integral that goes from 0 to 1, and our integrand was that fraction that they gave us here just a second ago. So that was let me make sure I got this right now, a tangent squared of x on top and an x squared plus 1 on bottom. Okay, so to do tangent squared, we've got to break that up and go tangent of x, close the angle, close the tangent, and square all of that. All over on the bottom, an x squared plus 1. And that should do that. Let me double check that. Yep, got it. And we're going to do all of that with respect to x. Okay, so that integral right there, they ended up giving us this ugly decimal of 0.345 if we were going to round that. So now we know that our left side, oops, wrong one. we know that our left side is 0.345. All right, and then from there, if we want to get f of 0 by itself, we're going to bring the f of 0 over here to the left, subtract the 0.345 on the other side, and we are going to get f of 0 equals, and if I got that right, the 0.5 minus that should be a 0.155, if I'm not mistaken, and hopefully that matches one of our choices. It does, and it looks like for 35, the correct answer is A.